The development of the periodic table. Antonio Lavoisier, a French chemist, attempted in 1789 to group the elements into metals and nonmetals, beginning the classification of elements by similar physical and chemical properties that the modern periodic table was based upon. 40 years later, Johann Wolfgang Dobereiner observed similarities in physical and chemical properties of certain elements. This research was the first suggestion that properties of elements are related to their atomic structure. Johann used his studies to arrange these elements into groups of 3 in increasing atomic weight and called them triads. In 1860, Karlsruhe, Germany, this list that Lavoisier produced was revised and published. Within this list, it was concluded that hydrogen would be assigned an atomic weight of 1, and that all other elements' atomic weight would be determined based on hydrogen. This decision strongly influenced the modern chemical classification by beginning the standardization of atomic weight by using hydrogen as a reference. John Newman, a British chemist, was the first chemist to arrange elements by increasing atomic mass. His main discovery, the law of octaves, showed that every 8 elements had similar properties. He therefore arranged the elements into 8 groups. However, he did not leave gaps for undiscovered elements, making his work flawed. This was due to a lack of belief that there were other elements existing. He also incorrectly grouped some unrelated elements together. Newman's work introduced the repeating pattern of element properties, helping shape the modern periodic table. In 1869, Dmitri Mendeleev created the most impactful framework on the periodic table. In this framework, Mendeleev arranged the elements according to their atomic weight. However, what was so significant about his work was that he left gaps for elements that were yet to be discovered. He arranged his work into rows and columns, later to be named periods and groups. The gaps allowed him to predict properties of unknown elements. He predicted elements like gallium and germanium, whose properties closely match his predictions when discovered. This was majorly significant in influencing modern chemical classification, as he established the periodic table's structure and conveyed the period nature of elements' properties. In 1870, Lothar Meyer produced a periodic table similar to that of Dmitri Mendeleev's. He, following Mendeleev's, left gaps for undiscovered elements, but he never predicted their properties due to a lack of accuracy. Both scientists received the Davy Medal in 1882 from the Royal Society. Meyer's periodic table supported the idea of periodic pattern among elements. Meyer's periodic table supported the idea of periodic patterns among elements and helped confirm the system later refined into the modern periodic table. Moseley started his research on the periodic table in 1913. He studied X-ray wavelengths from metals and calculated the positive charge in atomic nuclei. His work showed that elements could be arranged by atomic number. In 1913, Moseley discovered the Moseley atomic theory. This experiment and calculation of protons in the nucleus led him to classify the periodic table elements according to their atomic number. Anton Lavoisier, Johann Wolfgang Dobereiner, John Newlands, Dmitri Mendeleev, and Henry Moseley helped develop the modern periodic table. Their combined experiments and discoveries have conveyed patterns in element properties and have created a systematic way to classify them. The modern periodic table helps individuals predict chemical behaviors and design new materials. It is used across a wide variety of industries such as pharmaceuticals and electronics. The modern periodic table also portrays trends like electronegativity and ionization energy, all of which help chemists understand different reactions.